Hi, I'm Dave Williams, CTO of Massdriver, and today we're going to be looking at building a Massdriver bundle from an existing Terraform module. So as you can see here, what we have is a Terraform module like you would write to be consumed in Terraform. We're building a Kinesis stream here with an IAM policy for read, for write, and for manage. You can see there's nothing really special here. We have a variables file and we have an outputs file, just like you would if you were writing a standard Terraform module. So what we're going to do now is actually copy this module into a Massdriver bundle, and we're going to do that with the mass bundle new command. You can see we're giving it a name of AWS Kinesis stream. We are using the T flag because we're saying we're deriving it from a Terraform module. We're adding one connection, which is an IAM role, which will be used for deployment. We're passing it a path of /Kinesis stream, which is that module that we have here. We're giving it a description, and we're giving it an output of AWS Kinesis stream as the directory to put all these files in. Now that the command has been run, you can see we have a new directory, and in that directory we're going to have our Massdriver bundle and all those additional files. Now, because the module we derived from likely didn't have its own provider block and it was inherited by the parent, what we're going to do is have to create a new provider block for this module. So if we go into providers here, we're going to set up the AWS provider to deploy our Kinesis stream. So we're going to uncomment that and get rid of the rest of these comments. Now we're going to set up the provider block for AWS. So you can see here with region, we have this configured to actually deploy into the same region that a connected resource is in. However, for now, for the Kinesis stream, we're actually going to allow a user to define a region. Below this, you can see the AWS authentication, and this is the connection that we created, and it's going to be how we assign a role to actually deploy our Kinesis stream. So now let's add region as a variable into our Terraform module so that the user can actually select it. Here in the Massdriver YAML, I'm going to add a property called region. Its title is going to be region, and its type is going to be string. However, this isn't super useful. Let's just say that in our organization, the only regions we allow people to deploy into are like US East 1 and US West 2. By using this enum field, we're actually going to be able to tell the user which regions they have to choose from, which is much more useful than just having to guess. Now we're going to build our bundle, and you're going to watch as region is added to this new Massdriver variables file. The Massdriver variables file has a couple of useful things. So you can see the AWS authentication that we created as a connection. You can see the MD metadata object, which is all metadata that Massdriver will pass in, that you can use in your modules. And we see that new variable regions. Any variables that are unaccounted for in your variables file will be added when you add them to the massdriver.yaml file. Now let's add region into our required fields so that the user is forced to add a region in order to deploy. And now we're ready to actually publish this into Massdriver and take a look at what it looks like in the UI. So now we can search for our Kinesis stream. We can drag it on. We'll give it the name clickstream and add it to our canvas. All right, here it is. Let's click it and let's see the config. Okay, we have a bunch of fields. This isn't a lot more useful than a Terraform module. We just have a bunch of text input. We give the user very little indication of what they should do next. So let's start to clean this up. The first thing we're going to do is remove this name field. By diagramming your infrastructure in Massdriver, we actually create a naming convention. That naming convention is the project name, the environment, and the contextual name that you gave to the resource. For actually naming things in the cloud, we actually add a 4-letter suffix to handle any global name collisions that you might run into. So we're going to use that instead of letting the user supply a name, so that way when we look at our resources in the cloud, we know exactly where it came from and why it's used. Back in our editor, we can actually remove the name field from our required fields, and we can remove it as a property in the massdriver.yaml. We'll then have to remove it from our variables.tf file so that Terraform doesn't expect it to come in. And you'll see we now have an issue in main. A lot of references to var.name that we actually need to make into the naming convention that Massdriver provides in the MD metadata object. So we'll change var.name to var.md_metadata.name_prefix. All right, with that done, the name field should be gone, and we should actually be using the Massdriver naming convention by default. So now we publish the bundle into Massdriver to see the changes. Go over to the browser, and as we can see, the name field is gone. We can select a region, but we have some other fields that we have to think about. So there's two interesting fields here, stream mode and shard count. They are dependent on one another. So stream mode can have two values, on demand or provisioned. And in the event that it's provisioned, shard count is actually required, but if it's on demand, it is not. So let's make this a little easier for users to understand. Let's go back to our editor, and what we're going to do is go into our massdriver.yaml file, and we're going to create a new object that is going to contain those two fields. We're going to call this object capacity, and we're going to add it as a new field within our Massdriver YAML. So let's create a capacity attribute. All right. We'll give it a type of object. Its title will be capacity. It'll have one required field, and that required field will be stream mode. And it will have one property at the moment, and that is stream mode, which is what we already have here. It's just a string. Now the string, like I said before, can have two values, on demand or provision. So just like we did with region, let's set that up with an enum in our Massdriver YAML here. Now our users don't have to guess which value they can use. Now we need to make the dependent field shard count. So in the event that the user selects on demand as a stream mode, we're actually auto-scaling. So we don't need to show that additional field, but if it's provisioned, we actually do need to show that shard count field and validate it. So to do this, let's add a dependencies block. And this dependencies block is going to match the stream mode value in one of two states. In the event that the properties of capacity, in particular stream mode, match the value of provisioned, we need that additional field. So we're going to add another property. We're going to add the shard count property in, and we actually have it defined already, so we're just going to copy and paste that in and fix our YAML indentation. In this case, we're actually going to set that the shard count and the stream mode are both required in the event that the state matches the provision state. The other case is that the stream mode matches on demand, in which case we're not going to add that additional field, and we're just going to require stream mode. Now that the dependency is defined, we can actually remove the required block for capacity. We'll fix our YAML syntax here and publish that into Massdriver to see what that looks like in the UI. Now over in our UI, we can look at clickstream and look at our new section here, capacity, which it's two values, on demand and provisioned. In the event that it's provisioned, we see that shard count is there and it is required. So the next thing to do is start to set our limits on some of these fields. So if we look at the variables.tf file, we can see that shard count and retention hours both have mins and maxes. This is really easy to do with JSON schema. It's just a couple lines of code. So let's cut back to our editor and add those minimums and maximums. If we open up our variables.tf file, we can see here retention hours and shard count both have mins and maxes. You can see that retention hours, its max is 8760 and the minimum is 24. So let's add those in right now. By using the maximum attribute, we can actually set that maximum attribute to 8760, and the minimum attribute will allow us to set the lowest we can do at 24. Now we have to do the same for shard count. If we look back at our variables.tf, shard count's minimum was 1, and its maximum was 4096. So let's add those in with the minimum and maximum attributes again. And let's fix the spelling on maximum, and let's publish this into Massdriver. Back in our UI, let's test these validations. Our shard count is 9,000, which has to be less than 4096. So let's set this to something that'll pass and save. And now our retention hours must be greater than 24. Let's set it to 24, and we have a valid configuration. The next piece of usability to tackle is the shard level metrics value. So shard level metrics have a set number of strings that can be passed in for each shard level metric, and it is an array of strings. Just like with region and with stream mode, we can actually let our users know what the acceptable values are and select from a list. Let's go into our editor and do that now. Okay, if we scroll down here, and we look at the shard level metrics, we can see it's just an array with the unique items set to true, which means we can't duplicate a value. Just like with region and with our stream mode, we're actually going to provide all of the values for our engineers so they know what they can choose from. We're going to paste it in here and fix our formatting. Okay, now we can publish this into the platform, and let's see what it looks like. There we go. We have all of our shard level metrics. We can choose them. We can choose multiple, which is exactly what we want. And you can see we have a working configuration here. The problem is it is not super useful, right? Like the flow is a little interesting. Maybe we want to have users think about region first and then think about capacity. So let's look at how we do that with the massdriver.yaml file here. So you can see this UI order field. And we're actually going to specify just the order in which we want all of these properties to appear. So we're going to do region and then capacity, our retention time, and then finally we're going to do those shard level metrics. Let's publish this in and see what it does to the form. All right, and as you can see, region up top, then capacity. This flow is pretty good. Let's actually deploy this and create a Kinesis stream. So what we're seeing now is a message has been sent to our air-gapped provisioning engine, which is pulling the code that we've published into Massdriver and actually applying the Terraform and deploying it into the AWS account that we've set for our credential. So here we can see it start to run. We can see our Terraform is initialized, and our provisioning engine by default will run things like Chekhov. So our first step here is going to be to generate a plan, which we see here, and then use Chekhov against that plan to tell us if there's anything that violates compliance. Okay, this passed. Now we're going to validate OPA rules because we run OPA after to make sure that we're not violating any constraints like delete and recreate. We can fast forward now. You'll see we're creating a Kinesis stream, so we're just going to skip to the end. All right. 4 added, 0 changed, 0 destroyed. So we have that Kinesis stream and those policies deployed into AWS. Now the problem here is this isn't super useful. Nothing can connect to this clickstream. So we're going to need to create that artifact to allow you to actually compose modules and make a diagram. So let's head back to our editor and let's go to our Massdriver YAML first and actually add that artifact. So you can see here, properties is just an empty object. So we're going to need to fix that. And we're going to make one required output, and that is going to be called stream. And under the stream property here, we're going to use a predefined Massdriver artifact, AWS Kinesis stream. So this will validate that our JSON that gets created in Terraform is actually fulfilling the promise that it is an AWS Kinesis stream. To produce that artifact, we're going to use the custom Massdriver Terraform provider, and we're going to create an artifact. So we're going to give it a name. That name's going to be stream. We're going to set the field that we're going to output it on, and we called it stream. We are going to set the provider resource ID, so we can say like this is the primary ID of our Kinesis stream in the Massdriver platform. We're going to give it a contextual name so you can find it in the Massdriver platform. Next, we actually need to create the data for this artifact. So artifacts in Massdriver have two kind of top-level fields. One is data, which is for modules to connect to each other, and one is specs, which is for human-readable data. So we're going to create a spec here that's just going to tell us what the region in AWS that this artifact comes from, and that'll be US East 1 or US West 2. Next, we have two fields within data. One is infrastructure. This is going to be the resource name of the resource we're creating, so it's going to be the stream ARN. The other field is a security field, which is going to pass forward connection data, and we're going to use IAM for that. So let's first put in our resource name for our Kinesis stream, and next let's make an IAM field because we're going to use IAM security for this Kinesis stream, and we're just going to put in the three policies here. So we're going to put in a read policy first, and the policy ARN is going to be the policy that we created. Next, we're going to do the write policy. And finally, the manage policy. All right, now that this is done, we can publish into Massdriver and actually redeploy our resource to get that artifact. So you can see here, we now have a bubble on the right side, which is actually going to pass forward the artifact, but because we haven't redeployed, there's nothing coming out of it. We can kind of go over here into our artifacts tab and you can see there's nothing there. So now if we click deploy, and we kind of fast forward to the end here. All right, now that we have it deployed, we can actually go back into our artifacts tab, and we can see we now have a concrete object coming out. Is going to be to actually test that our Kinesis stream is working as we expect. So we're going to type in some commands using the AWS CLI. So our package name, because we use that naming convention, will be how we kind of access this. So we're going to type in a couple of commands. The first one is going to be putting a record with just the key test data. And you can see that that worked. And finally, we're actually going to pull from that Kinesis stream and pull that test data record. And there you have it. Test data is in the data that comes back.